In this video, we're going to take a look at how to use the 595 digital transmitter with the LMI 595 wireless antennas to collect data wirelessly with LMI's universal gauge interface software. Now, in order to do this, we're going to need our probes, our cables that connect those probes, and either a serial cable here or a USB to serial adapter like I have here. I will be using this for the purposes of our video today. So this is actually really useful if you have something like a laptop that you're going to, or a newer PC that doesn't have a serial port on it. Again, it's not necessary to have one as long as you have something like this to convert the serial information to USB. So, before we begin all that though, we need to take a look at the 595 and make sure that we have it set up correctly to transmit data to UGI. So, the first thing I'm going to do is turn on the 595. I'm going to hit the menu key here, and then I'm going to go down one to communications. I'm going to push the select button to select it, and then I want to verify that my format here is export 3. And then going down through here, we can also see that our baud rate is set to 9600 too. So those are two important things that we need to take a look at. Now, since I'm using the true position gauge here, along with this, I want to change the labels that I have here. Now, right now, and by default, the 595 ships with 2 flush and 2 gap, as your labels here. This is for an LMI 2-for-1 gauge, but if we're using the TP, we can go ahead and change these to better reflect the A and B axis of our probe. So, to do this, I'm going to hit Menu. I'm going to go down to Advanced Setup, press Select again, because I'm in Config Ports now, and then I'm just going to go down to port 2A. Now, currently my label says flush, but I'm going to make this my A axis. So I'm going to use the arrow keys to select A axis, and then I'll hit select here. And my cal span is also set to 10 mils, which the TP that I'm using only has a cal span of 4. So I'll need to change that as well. I'm going to take this, put that down to 0, come back here and make this 4. Press select to save it. And now also, I want to make sure that this read is set to off. This could be set to manual, but for our purposes today, we're going to use it set to off. I'm going to go repeat this process now with my 2B axis, which is currently reading as 2 gap. So I'm going to go to Menu, Advanced Setup, Config Ports, and then arrow down to 2B. Instead of having this one say gap, I want this one to say B-axis. Hit select to save it. Change my cal span again. I'm going back to 4 mils. Save that. Now, by default, the 2-for-1 ships with a 3 mil offset. So we're going to change this 3 mil offset here to 0. That way, when we have it in the master block, a 0 will read as a 0. Make sure our read is off as well, and go back to the menu key. Okay, so now you can see I have a couple readings here, and then if I use the back arrow key, I can also select my 200 probe here. So what I'm going to be doing next is I'm going to calibrate each one of these probes individually. Okay. To calibrate the 200, I need to make sure that I have my 4-pin cable plugged in to my 200, and then I'm going to plug in the other end of this cable into port 1 on the 595. I'm going to hit the menu key, and the first thing that should come up is calibrate. I'm going to hit select, and then I'm going to select port 1A for my calibration there. And then now the 595 is just going to walk me through the steps. So the first thing it's asking for is the calibration for the low step. the calibration for the high step, and then lastly the calibration for the master, or the middle position. Once I have that completed, it'll shoot back out to the calibrate menu, and then I'm going to push the menu button again just to verify this. So I should have 10 mils of travel between my low and my high steps here. So I got 450 there. I should be seeing 5.5 on the other side. Pretty darn close to it, 5.48, so I'm okay there. I'm going to verify my 0 position as 0. Insert that in the middle spot there. Next I'm going to calibrate my true position probe. So I want to make sure that I have this plugged into the number 2 port up here on top. And then I'm going to insert the probe into the OSM 1.25 calibration master here. Now for this, I have to do each one individually. I have an A axis that I'll have to calibrate and a B axis that I'll have to calibrate. So I'm going to start off with the A by pushing menu, calibrate, and then we'll go down to 2A. I'm going to rotate the end pin of my master block here to where it says low A, and I want to make sure that I have the probe pushed up all the way into the hole there. I'm going to push the select key to select my cal low. I'll then rotate the end cap, or the end piece here, 180 degrees to where it says cal high, master A axis. I'll hit the select key to accept that, and then I'm going to drop it into the calibration master sleeve, or the 0 sleeve. Let's put this right in here like so, and that should give me the center position for my A axis. And then we'll repeat this process for port 2B, or the B axis here. So I'm going to take this back out of here, put it with the flat side up into the master block, and I'm going to be looking at low B master here. Make sure that's in all the way. I'll then push select button. It's going to ask me for high, so I'm going to rotate this 180 degrees. Make sure it's pushed in all the way. Select, and then it advances to cal master. I'll then take this back out and drop it in the 0 sleeve again. And hit select here. Now when I go back to the menu, I should be reading close to 0 and 0. 0 and negative 0.01, so I'm pretty darn close to where I need to be. So what we have is we have both of our probes plugged in, and now we're going to attach the 595 wireless antenna to our 595 and to our PC. Now you'll notice that each one of these has its own ID here, and the IDs will have to match in order for this to work properly. Each antenna also has a little, what we call a heartbeat LED on the side that indicates that it's receiving power. So I start just by simply taking this and just plug it into the top here. I can use my thumb screws to tighten it down so it doesn't come out on me. And then with the other end, I'll be plugging this into my serial USB adapter. And this I will then plug into my desktop. Okay, so with those connections made, I'm going to click on Create a Part File, and we're going to go through these 6 required steps over here on the left-hand side of the screen. I'm going to start off with part file name and save, and I'm actually going to give the part file a name here, and I'm just going to call this one 595 wireless example. And the only other thing we have to do on the screen, that we actually have to do as a requirement, is give the part file a storage location. So if I click on this browse button here, I can click on OK and it will go to the default storage folder for it. But if not, I can select from my tree here anywhere on my hard drive to, or even network actually, to save my part file. Highly recommend just leaving it in the default though, so I'm just going to click on OK. And it will be created in C, Program Data, LMI Corporation part files. I'm going to go ahead and click on Next. And then the part file default screen, when we're dealing with a 595 wireless, we don't need to change any of these items here. So we can go ahead and click on Next and go to the part file gauges screen. Now, this screen is kind of the heart and soul of the part file, so it's very important that we get everything right and set up correctly in here in order to make our part file work. So I'm going to start off by giving myself 15 gauge points here as measurement points. And you'll see it automatically creates this Excel-like grid that I can work with. Now, since I'm taking TP readings, each one of those readings consists of both an A and a B, or an X and a Y, depending on how you're looking at it, axis. So I want to make sure that my first 10 are going to be specifically geared towards the true position, and then the last 5 points will be my surface checks that I use using the LMI 200 probe. So I could go through here under gauge type and manually select my DSI flush, DSI gap, which will be used for the true position, and the DSI point, which will be used for the 200. However, I can take a shortcut over here by clicking on gauge type setup, and then I'm going to select DSI flush for my first 10 rows. And you'll see that it automatically changes all these to DSI flush. However, since we're dealing with a B axis as well as the A axis, we're going to make this a gap. Every other one will be a gap. Okay, now we want these readings to come across together at the same time, our A and our B. So what I have to do now is associate each row of the A with each row of the B. So I'm going to select 2 with 1, 4 with 3, 6 with 5, 8 with 7, and 10 with 9. Now, for my final 5 here, these are going to be my surface checks. So I'm going to go back over to gauge type setup, and instead of choosing DSI flush or gap, I'm going to choose DSI point. I'm also going to change my starting row here to number 11, and then my ending row will be 15. Okay, and we'll see how those change. Now, the other thing I need to do is I can go back here and I want to give each one of these points a specific name. For each one of my true position, I'm just going to call each one SPCA and SPCB with a number. So, for example, SPC1A, SPC1B, and so on and so forth down the row. And then the last ones I'm going to call SBC 1 through 5. However, I'm going to call these surface, since that's what they are. They're surface checks. Okay, now with that done, I can also issue these to each their own screen. What this means that all the TP readings will appear on one screen, and then as soon as I take those readings, the screen will flip over, and then I'll see all my readings for my surface checks with the 200 probe. So I'm going to click on the first one here, and I'm just going to call this one true position. And then I'm going to drag and pull down here to number 10, and I'm going to click on fill. And now I'm going to call this surface checks. And still there. Okay. So the calculation we're not going to worry about right now. The mux port we don't even need to include in this, but our COM port is very important because that will show us which COM port our little antenna is plugged into. Now, if you're going directly into the back of your PC through the serial port, chances are it'll probably be COM1. If you're using a USB to serial cord like I am, it'll probably be a different number. So if we can see down here, mine's showing up as COM6. So I would need to either manually go through here and change all of these to COM6, or again using a shortcut over here, I click on COM port setup and just select 1 through 15. I click on OK, and you'll see those automatically change. Now, the span we don't need to worry about. The offset, we can add something in there if we need to have a permanent offset, say to, for example, to compensate for a fixture that was nudged a little bit incorrectly to one direction or the other. For right now, though, we're going to leave those at 0. And then we have our upper spec and lower spec, upper cautionary and lower cautionary, and our high reasonable and low reasonable. Now, in essence, these are just your spec values. What determines if a part is good or what determines if a part is bad. So your USL and LSL are those hard limits. Anything above 1 or below -1 will result in red showing up on the screen. Anything in between there will show up as green. I also have the option to set up a upper cautionary and lower cautionary level that falls in between my USL and my LSL if I want to show yellow, just to get a grip on I'm trending, I'm coming to the end of what's acceptable, but I'm still good. The high reasonable, low reasonable can be used if you want to alert your user to the fact that they are so far out of spec that something's just not right there. The reading is unreasonable. That means that either they didn't calibrate the probe or they didn't throw a clamp or something like that on the fixture, and it'll show up as blue. Now, if you want to use that, just go ahead and set it. I would recommend maybe doing double what your upper spec and lower spec are. If we leave it at 100, though, it'll be so far out of range that we don't need to worry about it. So on this example, we're just going to be seeing red and green on our screen. If I need to invert a reading, I can do that here by just clicking in the checkbox here. I can also deactivate points if I'm no longer taking measurements for those particular points, just by unselecting this active. However, if we're putting a point in our routine, chances are we want to capture a measurement for that routine, or for that point in the routine. So we're going to leave all these checked. The frequency we can leave NA as well, since we're not going to be using that with the 595 wireless. Now on the part file graphics screen, we can add an image if we need to. I don't have one set up specifically for this program, but just as an example, I'll choose one from my menu here. I click on the image button here, and that opens up C Program Data LMI Corporation Graphics. So if I have a graphic that I can use, I'll just drop it in this folder and then choose that graphic from this list here. I'm going to use this one here for mine, even though I know it's not really set up for this particular example. But if I click on each one of these boxes, I can drag the measurement points to where they actually are on the fixture, which in turn makes it easy for the operator to follow, sort of like a road map, to get from point A to point Z, or in our case from SBC1 to SBC5. Now, if I want to, I can also increase the font size of these so it's a little bit easier to read. So I'm just going to bump all these up to 20, and then I'll need to do some rearranging here. But again, this just serves as a roadmap for the operator. Okay, you remember how we had the component screens on our last window here? What we're going to do is we have our true position one. Now we're going to switch over to the surface check. And then we're going to add that exact same image, and we'll increase our font here so we can capture those checks. So here would be our surface 1, surface 2, surface 3. You'll notice that I'm double clicking on SBC 5 and SBC 4, and that will switch the orientation of the characteristic name and the box around. Alright, when I get my graphics like I want, I go ahead and click on Next and move to the part file input screen. Now this is something that is completely definable and up to the user and operator to input, so we're not going to do anything like this here, but if you do want to add something for trace data such as operator's name or operator's number, shift or building codes or anything along those lines, this is the screen where you do that. You can either consult the manual or give us a call here at LMI and we can walk you through that process. I'm going to click on Next again, and now we're just going to set up a very basic part file export so we can see the data that we collect. Now, in order to do this, we have sort of three main sections of the screen here. The upper section is our location, our name, and then the extension that we give it. Now we can select anywhere on the computer to store the data. However, I'm just going to leave it in the default folder, which, like the part file storage itself, is going to be located at C, Program Data, LMI Corporation, Part Files. I'm going to give this one a name as Wireless 595 example, and then I'm just going to put the word data behind it since that's what it is. For my export extension, I'm going to set up a real quick and dirty comma separated value file which can be opened up by Excel, and that uses commas as a delimiter here, so I don't need to change anything in my box here. So the first thing I want to do is I want to get the date and time, so I'm going to set this up by first creating my header file. And then I want to capture all of the readings. Now in order for me to do that, I just click on All Characteristics, and what this will do is it'll insert every single point. So our characteristics SBC 1A through Surface Check 5 will all appear on our export. And here's kind of an example of how that will look. Again, this is just the header that we're setting up now. This won't be the actual data. So I'm going to go ahead and go back here to my field drop down, select Start Header, and add that header in. Now I'm going to click on Start Header, and I want to move that up to the top. So now anything that comes between my start and end header is my static data. These are just the labels for each column. And then from this drop down here, I can get my actual dynamic data, or this is the things that will change every time we run the part file. So I'm going to nab the date, the time, and then all readings. And again, you'll see this show up down in the export view down here. Okay, so that's real simple, quick and easy part file export. The last thing I need to do is click on Add Export, and then click on Finish. Once I do this, I click on Yes to save the file, and it will take me back out to the home screen. And from here, I can click on Run a Part File, click on Browse, select the part file that I want to run, and then click on the Run button. And that's all there is to it.